we are summoning the demon. You know all those stories where there's the guy with the pentagram and the holy water, and he's like, yeah, he's sure he can control the demon.
Unexpected occurrences have led to the release of startling information on CERN and its enigmatic Large Hadron Collider, which is both the scientific emblem of God and the means by which the cosmos has been formed. Although this was written off as a web of conspiracy and debate, recent information from CERN authorities raises the possibility that some of these allegations are genuine. In fact, a number of the alarming aspects caught the public off guard, and many demanded that the new endeavor be discontinued. Why is there a problem with the Large Hadron Collider? What is ahead for our planet as a whole, and for this monumental scientific endeavor? Come along as scientists from CERN claim to have unlocked a doorway to a parallel realm. The Large Hadron Collider is unique among scientific equipment and developments, either in terms of its aim or category. The pride and happiness of modern scientists comes from this heritage, which is the largest and most potent particle collider in the world. Nestled beneath the French-Swiss border in the verdant setting of Geneva, this impressive location is the gateway to discovering the vast and fascinating subatomic realm. The construction of giant science merry-go-round, which is 100 meters above the Earth, took 10 years and involved the cooperation of hundreds of scientists and specialists from all over the world. The world's first Large Hadron Collider was created as a result of Einstein and Faraday's commitment and sacrifice. The collider smashes atomic particles in a controlled setting with the sole goal of studying quantum particles instantaneously. The scientific community was able to create collisions with energy of up to 3.5 teraelectronvolts per line in 2010 thanks to the Large Hadron Collider, LHC. The voltage is around 6.5 teraelectronvolts each beep, according to the most recent data from the LHC. While this may seem like a little figure to the general public, it is startling to the ordinary physicist. To put it more precisely, moving at the speed of light requires 6.5 teraelectronvolts of energy. The LHC material will blow up if an energy block of some kind is present. The explosions produced by collisions at the Large Hadron Collider produce an incredible shower of large particles that is unobtainable from any other accelerator. With the exception of a few detectors at the Large Hadron Collider, it is currently difficult to follow these particles as they are going in all directions. Every year, the LHC's experiments generate almost 15 petabytes of raw data. You may appreciate the magnitude of the material CERN must sort through each time the LHC fires by keeping in mind that 1 petabyte is equivalent to 1,000 terabytes. While a great deal of public worry and discontent has been directed at the LHC experiments, CERN has made it abundantly evident that this research is both necessary and vital. Impact patterns and collisions at the Large Hadron Collider, as well as in the invisible subatomic realm, happen on a daily basis, according to CERN. Since this is being done in a controlled atmosphere, there should be no danger if the scenario is repeated. As you are aware, scientists have long harbored the desire to strike things at speeds approaching the speed of light. A portion of the kinetic energy of a collision between two protons can be transformed into mass. Furthermore, new elements may be made into something new by combining them with their counterparts. The possibilities are unlimited since these new particles can merge with already existing particles by crashing protons to form new ones. Closing the door on the enormous potential for scientific discovery would be equivalent to shutting down the Large Hadron Collider. When you consider the uncertainties surrounding the current standard model of particle physics, you can see why CERN chose to start operating the Large Hadron Collider. Unbeknownst to many, the Large Hadron Collider is capable of much more than just pushing things into odd positions. In reality, scientists may investigate the predictions of several particle physics theories thanks to this special study tool. Additionally, strong ion beams can be produced by the Large Hadron Collider to explore hitherto unexplored regions of particle physics. CERN researchers are highly intrigued about this discovery because of its enormous potential. The enthusiasm culminated in 2017 when the Large Hadron Collider produced an unexpected discovery that humiliated the sub-collider's detractors and sent shockwaves across the scientific world. The Higgs boson has been discovered. See, in 2017, the boson particle, or Higgs boson, was finally found by the Large Hadron Collider, fulfilling a long-held hypothesis in particle physics. Higgs particle or God particle are two of the numerous names for this particle. Still, it is a crucial component in the paradigm of particle physics. Scientists claim that bosons are the essential building blocks of the Higgs field, which imparts mass to all other fundamental particles, including quarks and electrons. The scientific world has long argued whether or not such a thing exists. Boson particles have not been detected in reality, hence the majority of the knowledge regarding them is theoretical in nature. You can only imagine how happy CERN scientists were to finally announce that boson particles had been found at the Large Hadron Collider. We credit the European Organization for Nuclear Research's, CERN, ATLAS and CNS experiments for this significant finding. Along with many additional observations and direct decay of a double Z boson, scientists have found strong evidence for the existence of the Higgs boson particle. Nevertheless, there is not much time to thoroughly examine the Higgs particle because of its fast degeneracy. Even if the Higgs theory and the boson particle's existence have been verified, there is still a great deal we don't know about the uncertainty. Consequently, CERN remains dissatisfied with this explosion. Actually, the organization is attempting to descend into mystery like a rabbit hole and finally solve all of the riddle's hidden facts. Currently, CERN physicists are searching for methods to quantify the characteristics of the Higgs boson and particles associated with it. This desire will come true thanks to upgrades like the high luminosity upgrade, which the LHC just revealed, making the facility a more potent device. Here, brightness is a straightforward measure of accelerator particle activity that is correlated with the quantity of collisions that take place over time. By converting the LHC to a high luminosity LHC, more data will be produced to observe uncommon phenomena and greater collisions will be possible. Perhaps this time, researchers will uncover more enigmatic boson particles like fermions, hadrons, and gluons. Similar to how atoms and molecules are bound together by the electromagnetic force. Hadrons are subatomic composite particles composed of quarks held together by the strong force. Mesons and baryons are the two categories of hadrons. Mesons are made up of one quark and one antiquark, whereas baryons are made up of 3 quarks. This categorization is based on the quantity of quarks present. A type of basic particles known as fermions adheres to Fermi Dirac statistics. Quarks, neutrinos, and electrons are also among these particles. While all of these fascinating facets of particle physics will be thoroughly explored, the primary focus will be on the idea of the Higgs boson outside of the context of particle physics standard model. Predicts the existence of 5 distinct Higgs boson kinds. The majority of objects created by LHC experiments are transient, which is a major challenge that CERN specialists are currently working to overcome despite the LHC's unrealized potential. A fraction of a second is all that certain particles have before they collapse into smaller ones. Interestingly, even when all particle detectors are located in one location, some particles remain undetected. This is a drawback when studying some subjects since it is impossible to examine them for brief periods of time in their stable condition. Researchers are currently considering ways to maintain these objects in a stable condition and further their scientific endeavors. The fundamental motivation behind the discussions about constructing more particle accelerators beyond the Large Hadron Collider is likewise this enigmatic state of affairs. CERN will be able to examine the subatomic realm with greater accuracy than previously thanks to its new high luminosity LHC. However, There was a lot of disagreement and public alarm as word spread of a larger, more complicated tragedy. Tales about the LHC's impending demise continue to spread throughout the globe, and many individuals are still advocating for its closure. Since the announcement of the Large Hadron Collider by CERN many years ago, there have been several fears among the scientific community. Many are concerned that the collider's billions of subatomic collisions would surprise them. It can be risky for many scientists to smash numerous particles apart at the speed of light, particularly when you have no control over what will be created in the collision. Certain specialists maintain that natural subatomic collisions vary entirely from artificial collisions at CERN and are part of a distinct process. Nevertheless, other experts suggested that something sinister and enigmatic, something perilous and dangerous, might be at play despite the surprise. Many academics have expressed concern about this unsettling notion, which holds that CERN may be able to establish a link to another place. If you enjoy science fiction, you are probably aware of the numerous ideas that contend that there are numerous parallel universes with subtle differences and similarities that exist alongside our own. According to the hypothesis, there will be an endless number of universes, each with a unique population of stars, galaxies, and even sentient species. The inflation hypothesis, which was developed after the Big Bang, when the cosmos quickly expanded and grew greater than it had been previously, lends more credence to this concept. According to certain theories, inflation will stop in this planet, but will still produce other ones. Many people hold this hypothesis to be true, despite its disagreement in the scientific world. This is especially true in light of several horrible occurrences that have occurred recently, such as the Mandela effect. The phenomenon known as the Mandela effect occurs when several people mistakenly recall the same object or event. Over the years, several amazing examples depicting this phenomena have been documented, and new ones appear each. The fact that this event is taking place globally is what makes it so amazing. This begs a few questions, including what triggers the Mandela effect? What impact does it have on people globally? The Mandela effect began shortly after CERN constructed the Large Hadron Collider in 2008, which is one of its ironic aspects. Reported by Fiona Broome, a woman. Though he got out of prison, ran for president, and passed away 2013, he thought Nelson Mandela had died in prison in 1980. That had the same recollection perplexed him. He started to feel lightheaded when more research indicated he wasn't insane. However, the question of why or what makes this odd remains unanswered. That is, until some hoaxers began pointing the finger to CERN. These ideas hold that the 2008 construction of the Large Hadron Collider at CERN disrupted the structure of the cosmos and restored equilibrium. The hypothesis further clarifies that the erroneous recollections that people experiencing the Mandela effect claim to have are memories of our previous reality. While this may come as a surprise, several informed individuals have stated a comparable reality. Professor of Science Max Laughlin is one of the most ardent supporters of this idea. Laughlin recounted some of the miracles that people have thought about CERN since she, at the age of 13, said that CERN erupted into our world and brought us into balance. Machines that take the world by surprise. Laughlin won over hundreds of people to his way of thinking through his followers. Furthermore, scientist Stephen Hawking cautioned throughout his life that tampering with God's word might ultimately result in the destruction of our planet. Because of all of this, a lot of common people and science enthusiasts worldwide are wondering if CERN erred when it destroyed our planet in the pursuit of finding particles and exploring the quantum realm. A few prominent conspirators even charged the group with purposefully leaving the door open in secret. Some claim that these portals serve as entrances to other realms as well as interdimensional portals inside our own. There is conjecture as to who or what enters our world through these portals, from ghosts to aliens to fairy tales. Many people are curious in CERN's Large Hadron Collider and the amazing concept of opening a doorway to weird, unknown dimensions. In an effort to find a more effective approach to move the company forward, CERN is now illuminating the next generation of scientific findings while continuing to offer these new discoveries to the public and media. However, because the public and certain elites were preoccupied with gloomy issues, the organization was unable to take any action. An increasing number of individuals draw attention to CERN and its unexplained disaster each year, which sparks debate and events for them. For instance, there have been rumors that the 2016 earthquake in Italy was caused by the Large Hadron Collider. There is a rumor that a high voltage was sent into an Italian laboratory 250 miles distant by the Large Hadron Collider. He continued by saying that CERN purposefully raised this blood pressure in order to open a doorway to another realm. The fact that this assertion originated from a reliable source rather than some random person with a social media account contributed to its rapid dissemination of information. Although CERN refuted the accusations right away, the public's interest persisted. Locals soon started talking about the enigmatic storms and weather that passed over the LHC during its enigmatic functioning. Images of this storm have already circulated widely on the internet, leading many to conclude that CERN had unlocked a strange door. But as CERN conducted scientific tests, one of the most bizarre and unsettling incidents of that year put the organization in grave danger. There was a potential murder mystery just in front of the movie theater. In the 1-minute clip, a woman can be seen in the center of a group of males wearing hoodies and dressed in black who are standing in front of the Narrage monument inside the CERN building. Following a brief exchange of sluggish and peculiar motions, the woman was pushed to the ground and fatally stabbed. After the unsettling photos went viral on the internet, people quickly began criticizing CERN and posing questions. But according to the media, official organizations and spy services like the European Organization for Scientific Research, CERN, this was a fake and inexpensive performance put on by certain persons. However, the crowd thought quite differently. In fact, there are hints throughout the movie that point to this horrifying incident as a CERN theater production. The fact that the black perpetrators of this heinous crime wore it around their necks first revealed that they were actual laborers. The movie's lack of actual location shooting is another issue. Up until the woman was stabbed, the man filming the scene hid in a tall building nearby and said nothing. The man turned over in fright at this point, gasping in shock. This man went somewhere nobody expected to go and encountered something terrifying and unexpected. It's a common opinion among Ninas that the pictures shot lack context. This happened at night, in complete darkness, and with no background noise. Furthermore, CERN facilities are more than simply a public performance space. Therefore, who would have the audacity to hold such a demonstration within a government establishment? What's more, why was the murderer able to get into CERN? By labeling it a fraud, on the other hand, the organization is being religious and obviously trying to hide its tracks. However, the message being transmitted at this time is not odd. Many people speculated that the passenger automobile had crashed following its 2008 introduction, believing it had arrived from the future with the intention of causing harm. In addition, there was a rumor that travelers had harmed the magnet, which led to the experiment's final cancellation. It's a rumor, but you can't help but wonder whether the general concern that the Large Hadron Collider will rupture space-time has materialized already. Astronomers have just discovered fractures in Earth's magnetic, and once more, fingers are crossed at CERN. It is one thing to formulate a hypothesis. It is quite another to prove it. These massive conspiracy ideas and charges cannot hold up in the absence of solid proof. Therefore, CERN cannot assume any blame for any of the difficulties described unless more proof proves any or all of the plots and rumors. There are further proposals to improve and scale up the collider. According to CERN experts, Collisions will strike things 10 times quicker than they do currently between 2029 and 2042. The website will also be modified to improve exploration and learning. This is fascinating, and you can't help but wonder what kinds of discoveries these scientists may uncover. Or, on the other hand, what global catastrophe this could lead to. Time will tell for the time being.
It's possible that CERN has found something so amazing that it changes everything we thought we knew. This famous center has been at the center of important research since the 1950s, but it has always been on the edge of what scientists know. What does this shocking find mean for US? Let's learn more about this shocking story. Putting the universe's secrets on display, the Large Hadron Collider is one of CERN's most well-known projects. It is the biggest particle generator in the world. In a loop, it's over 27 kilometers long and cost more than $4.5 billion. A lot of people say this money was well spent because the LHC has led to some of the most important finds in the past few years, like finding the Higgs boson and other particles that were not known before. Over 11,000 laps per second, this huge machine can speed up different particles around its loop until they are almost moving at the speed of light. This is possible because of very strong electromagnets inside the accelerator that make a magnetic field that is over 1,000 times stronger than the Earth's magnetic field. Some people were concerned that making such a strong magnetic field could harm devices in the area and even the magnetic field of the Earth. When these particles hit their top speed, which is 99.91% of the speed of light, they are made to crash into each other. These powerful crashes release a lot of energy and different particles. Particle showers are made when particles hit each other and spread in all directions. They only last for a few hundredths of a second before they disappear. With different kinds of particles, scientists can find brand new particles in these bursts. Around the impact sites, ultrasensitive monitors are put in place to record all the information from each one. These studies have yielded a huge amount of information that helps us learn more about the basic parts of the world. The work being done at CERN keeps pushing the limits of what we know, making us question what we think we know about the physical world, and leading to the creation of new tools and ideas. The most surprising thing is how much we still don't know about the world. A lot of people work at the Large Hadron Collider, which is where scientists from all over the world gather a lot of information from interactions between very small particles. Scientists carefully look over the more than 15 petabytes of raw data that these tests make every year. It was a big deal for the LHC when it stored more than 200 petabytes of data on its tape banks in 2017. To give you an idea, a petabyte is the same as 250,000 films. Scientists always look through data for anything out of the ordinary. A strange thing was recently seen with a particle type known as the beauty quark. There are different kinds of quarks, which are the building blocks of everything. According to the Standard Model, which is a way of thinking about how basic particles behave, the beauty quark should break down into lighter particles called leptons, which could be an electron or a muon. But the LHC data showed something strange. Beauty quarks were turning into muons 70 times more often than they were turning into electrons. This should normally happen about half as often as it does now. Some scientists think there might be new physics beyond the Standard Model because of this strange ratio. It suggests there might be a new type of particle involved. Finding a new particle could change how we think about physics and give us answers to many questions that we still don't have. There are 4 basic forces, but the Standard Model only talks about 3 of them. These are the electromagnetic, strong, and weak forces. It doesn't talk about gravity or dark matter, which makes up most of the universe. This strange thing about the beauty quark could lead to important finds. It could reveal physics we don't fully understand and change the way we think about how the world works. Scientists are still very interested in finding this new particle and learning about the forces it might reveal. This search holds the promise of giving them greater insights into the mysteries of the universe. New results from the LHC make us question what we thought we knew about particles. New lethal forces with the LHC. The strange event makes scientists think that what they know might not be full, which leads them to look for new ideas. A few months ago, the Large Hadron Collider found data that didn't follow the normal rules of particle physics. Sometimes different effects happen, and that's okay. But experts paid a lot of attention to this case. They are now paying close attention to this odd result to figure out what it means. People are excited about Z prime, a possible new particle. We haven't seen this particle before because it's so weak. It might be a new type of power. Scientists believe that this force may work with electrons and muons in a way that is different from how other forces do. Things could change a lot if they keep this new force. They have been looking for years for clues to help them figure out big puzzles of the world, like what dark matter is and what the Higgs boson's real job is. Some people even think this new force could help bring together all of nature's basic forces, which is one of the main goals of physics. It would be great if Z prime were real because it would help us understand and answer some of the most important questions about the world. The study that is going on at CERN could help us understand everything around us in a whole new way. An interesting experiment at the Large Hadron Collider, LHC, makes particles move at 91 times the speed of light. These particles are sent in different directions, and when they meet, they hit each other very hard. This clash isn't just a cool science trick, it also makes a lot of new particles and a lot of energy. When these particles hit each other, they scatter in all directions. However, they only stay spread out for a short time before most of them disappear. There are very sensitive monitors right where these tests take place. It is the job of these devices to pick up every detail from these quick encounters. They are carefully put around the collision points. A huge amount of information is being gathered. A lot of data is sent to the LHC every year, more than 15 petabytes. Researchers spend a huge amount of time going through this huge amount of data very carefully in order to deal and study it. The LHC had saved more than 200 petabytes of data in its big tape libraries by 2017. Just to give you an idea, a petabyte can hold around 250,000 movies. They may ask you why they gather so much information. The action of a certain type of quark called the beauty quark is one of the many interesting things that have been found. A quark is the building block of matter. There are different kinds of quarks, and each has its own qualities. These types can change quickly and almost instantly become other particles. It only takes a trillionth of a second for the beauty quark to change, but recently it did some strange things that scientists didn't expect it to do. Current ideas say that when beauty quarks change, they should each become an equal number of leptons, which are lighter particles like electrons or muons. At the LHC, beauty quarks changed into muons 70% of the time, which is a lot more often than into electrons. This strange discovery makes me think that these changes might be caused by an unknown particle, which could mean that there is new physics we haven't found yet. This could mean a new particle with a power we don't understand. This could change what we know and make the standard model, which is the main scheme of particle physics, bigger. The standard model is a good way to understand particle physics, but it's not perfect. These strange changes in quarks bring up big questions that make the model less full. There may be new basic forces or particles about to be found. The ongoing work at the LHC is not only studying the depths of particle physics, but it could also change how we think about the basic forces and structures of the world. Let us now look at how these new findings might affect our main theory of physics. The search for the elusive Z-prime particle, the standard model of particle physics, talks about three basic forces: the weak, the strong, and the electromagnetic. It doesn't explain gravity or dark matter, though, which is what most of the world is made of. Scientists recently found something strange in their tests that didn't go as planned. Because the Large Hadron Collider, LHC, has so much data, it often gives experts results they didn't expect. This one, in particular, caught their attention and led to more study. Scientists think that this strange event could point to a new fundamental force and a new particle, which could be named Z-prime. This particle might carry force, but it is thought to be very weak, which is why no one has seen it before. Some people think that Z-prime might interact with electrons and muons in a way that is different from how known particles do. However, it is still not clear how it fits in with the other particles in the Standard Model. It would be a huge step forward in physics to find a new particle that can carry force. Some of the big questions about the world that it could help answer are those about dark matter and the Higgs boson. Some experts even think this could help bring the basic forces together, which is a goal that has been worked on for more than 100 years. A particle collider called the Large Hadron Collider was built by CERN from 1998 to 2008. Elon Musk praised their work on it. Over 10,000 scientists from over 100 countries worked on this huge project with hundreds of organizations. The collider is about 175 meters below the ground in a 27-kilometer tunnel on the border between France and Switzerland, close to Geneva. The LHC has broken energy records since it started running. The first collision reached 3.5 tera-electron volts per beam, which was almost 4 times the previous world record. It was later made better so that each beam could hit 6.5 tera-electron volts. Musk said that the LHC can speed up both proton beams and lead-ion beams, though proton beams are the most common type. The LHC tries collisions between protons and lead ions once a year for about a month to look into different particle physics ideas. These ongoing tests are very important for learning about the basic building blocks and forces of our world. That's not all the fun there is to it. People all over the world who study physics are interested in the Higgs boson, which is often just called the Higgs. This very small particle is connected to the Higgs field and stands for the energy that comes from it, like waves in the ocean. It's different from other particles because it doesn't behave like basic particles or particles that carry forces like electromagnetic fields or nuclear reactions. Scientists have been working at the Large Hadron Collider at CERN, which is the world's biggest particle collider, to try to figure out what the Higgs boson is. It is here that very fast particles crash into each other, making new particles like the Higgs and exposing them. When scientists found the Higgs boson on July 4, 2012, they were very proud of their big accomplishment. They mostly found it by watching it break down into 2 types of particles, photons and Z-bosons. Z-bosons are particles that are involved in weak interactions. The story didn't end here, though. When the Higgs boson was found, it led to new questions in the field of particle physics. Experiments at the LHC, especially those by the ATLAS and CMS teams, have been learning more about the Higgs boson. The proposed high luminosity upgrade of the LHC in 2029 will make this study a lot more useful. This update will make it easier to find rare events that current theories might not fully explain. It will do this by increasing the number of particle collisions. Next, we'll look at how these new ideas affect studies that are still going on at CERN. CERN's quest for 15 million Higgs bosons. CERN thinks that they will be able to make 15 million Higgs bosons every year after the update, up from 3 million in 2017. This rise might help find different kinds of Higgs bosons. Some ideas say there could be up to 5 types, with some showing up less often than others. That being said, scientists already had strong proof for a type called the magnetic Higgs boson before these improvements. The trip doesn't end there, though. Scientists think that studying the Higgs boson will help them figure out more about the world. Every experiment adds a new piece to the puzzle, and the big discoveries that come from them could help us understand the basic forces and particles that make up everything. Scientists are getting more and more excited because they are about to make new discoveries that will lead to scientific progress and a better understanding of the world around us. The Higgs field was a very important thought right after the world started because it changed the way space and time are organized. This field is what makes matter behave the way it does and gives particles their mass. Space would be empty without the Higgs field and the Higgs boson. There would be no atoms, stars, or life. The media mostly gave the Higgs boson the name God particle after it was discovered. The dramatic name comes from Leon Lederman, a scientist. He first called it the goddamn particle because it was so hard to find. Lederman wrote a book about it in the 1990s. He wanted to call it the goddamn particle, but the authors changed it to the God particle to stay out of trouble. A lot of people had different ideas about how this name related to faith and science. The Higgs boson and its field are very important. Particles would not have mass without them. There would be no galaxies, stars, planets, or life without mass. This is why the term, even if it's dramatic, makes it stand out. Higgs boson research is still going on to learn more about the early world and how it stays fixed over time. The Higgs field is unique because it gives empty space a base level of energy, which is necessary for the universe to exist. They believe that if they can figure out the energy of this field, they can explain why the electromagnetic force has an endless range, but the weak force doesn't. By making pairs of these particles, they are also looking at how Higgs bosons interact with each other. It's still not clear what the Higgs boson's own mass is, even though it gives other particles mass. The idea doesn't fully explain why its mass isn't unstable because of changes in quantum mechanics, which would make space less empty. Scientists are always looking for more particles like the Higgs boson, even though this won't happen for a very long time. Finding these could help us figure out what the universe's basic forces are and could even lead to new physics that we don't know about yet. There is even more to the Higgs boson's complexity. Scientists are also trying to figure out how the Higgs field fits into the bigger picture of how the universe has changed and stayed stable over time. Getting more information is important because we need new physics ideas to explain how the Higgs boson's mass stays stable. It is also suggested that when possible, higher energy colliders be used. Even after 10 years, this idea still keeps a lot of scientists busy all over the world. Scientists have been trying to figure out the Higgs boson for a long time. It was first suggested in 1964 and then found in 2012. It's puzzling why it took so long to be found. It's hard to find this particle because it's quite big and naturally unstable. A high-energy collider was used to focus a lot of energy in a small area so that it could be made. After being created, Higgs particles break down very quickly in a lot of different ways. However, only a few of these breakdowns can be seen clearly because of other things going on in the background. As new science comes out, it leads to big questions and crazy ideas about what CERN does. Researchers made some of the biggest and most advanced devices to look for these particles as part of their quest to learn more about the Higgs boson. It took them hundreds of billions of proton collisions to find the Higgs boson's unique mark. This wasn't the worst part, though. Some people are still not sure if the projects and findings made at CERN will lead to big steps forward in science or, as some fear, to terrible results. People who believe in conspiracies have said some scary things about CERN's work. A common idea is that CERN's work with very fast subatomic particles could accidentally cause terrible things to happen, like opening a doorway to a dangerous world. That being said, CERN has said that its work on making antimatter will help us learn more about matter and mass. It is made up of tiny particles whose charges are the opposite of those in matter. Some ideas about the Big Bang say that antimatter formed at the same time as the universe. Even though it's not common, antimatter should be as common as matter. It wasn't the only strange idea, though. Some people think that CERN's tests might change our reality, possibly sending our world into another dimension and messing up a lot of people's memories. This is called the Mandela effect. Last but not least, there has been talk about claimed human sacrifices at CERN since a video from 2016 showed a fake ceremony taking place on the grounds of the facility. Later, CERN said that this movie was fake. A lot of people talked about the video online, which showed people in hoods what they said was a fake ceremony. But a spokesman for CERN said it was just a bad joke. Scientists have mostly ruled these ideas out, but they are still the subject of heated discussion and interest about the scope and effects of CERN's experiments. However, this wasn't the end of the story. People talk about CERN's work and wonder what will happen next because it is so interesting. It's still not clear if the cops began an investigation after a very bad incident. People were interested in CERN again on July 5, 2022, which is not a surprise since it is often at the center of strange ideas. When things started up again after 3 years of upgrades and maintenance, the internet was full of different ideas. These ideas might be scary for science buffs, but it's clear that CERN's goals don't include making portals to other worlds, whether they're hellish, futuristic, or something else. Are we ready for what might happen if we find out what we don't know about particle physics?
The world's most sophisticated nuclear device, the Large Hadron Collider, LHC, finally went online in September 2008, following years of anticipation. The European Organization for Nuclear Research designed it, and building it is an extremely intricate operation. The Large Hadron Collider has advanced our knowledge of the cosmos over time. However, scientists are extremely interested in a recent breakthrough. A startling finding was revealed by CERN scientists after operating the Large Hadron Collider at full capacity. Since then, a plethora of explanations have been proposed by scientists to account for this defect. What became of the catastrophe, and how does it impact our ongoing and upcoming research? As we learn more regarding all of this, stay tuned. This particle collider is the biggest and most potent in the world. Its history is as intriguing as its intended use. It is more than simply a machine. The European Organization for Nuclear Research, or CERN, is a shining example of global collaboration and scientific inquiry. It started during World War II, when Europe was getting over a significant war. It was first used in the years following World War II. Famous scientist Louis de Broglie suggested creating a united European laboratory in 1950 as a way to boost peace cooperation and spur scientific innovation. Soon after, in 1952, the CERN Convention was signed by 11 nations, establishing the organization. Located near the French-Swiss border, CERN was established in 1957. Particle accelerators are required to make this happen. These enormous devices accelerate materials to almost the speed of light, then put them together to understand the fundamental elements of the cosmos. Let's go back in time to the 1980s, when the concept for the Large Hadron Collider was forming. The desire for more potent machinery to probe deeper into the secrets of matter grows as scientists become more demanding. With a ring of superconducting magnets and detectors spanning 27 kilometers, the LHC is regarded as the biggest and most potent particle accelerator in the world. The Large Hadron Collider is an incredible project in and of itself, with construction having commenced in 1998. Thousands of scientists and specialists from across the globe must work together to complete this enormous circle, which is situated 100 meters below the surface. After 10 years of construction, the LHC was prepared to start its historic trip in 2008. Both the difficulty of the Jura Mountains and collisions from the world above are avoided by the depth. This saves a great deal of money since fewer vertical lines need to be dug. Ultimately, with so much space underground, who would want to purchase pricey land above ground? What is this enormous ring on the ground used for then? It accomplished its initial collision in 2010 with an incredible 3.5 tera-electron-volts per beam. That is over 4 times the previous world record, to put things in context. And this is only the start. It now has a rating of more than 6.5 tera-electron-volts following several improvements. Imagine a collision between 2 matter beams that are moving almost at the speed of light. For you, that is the Large Hadron Collider. These fast-moving parts come together and clash at 4 distinct locations, 7 keepers, each built to watch and expose the numerous events generated by these collisions, wait impatiently around these sites. Every year for a month, the LHC shifts its emphasis from smashing protons together to heavy ions like lead. It's similar to a machine-only yearly festival. Our inquisitiveness about the cosmos holds the solution. The Large Hadron Collider is used by physicists to test some of the most enigmatic particle physics hypotheses. Studying the enigmatic Higgs boson and finding evidence of a vast particle family from supersymmetry theory are of special interest to them. Are you familiar with hadrons? These subatomic particles are made up of little quarks. Consider them to be the protons and neutrons building components. This chemical gives rise to particles when they collide, which is how the Large Hadron Collider gets its name. A lot of things are limited edition and cannot be obtained in any other manner. Thus, any mishap within the vast subterranean ring resembles a massive detonation. The universe's light, its elements, and the forces uniting them will then be visible to scientists. Above ground, there is a structure equipped with all the tools required. Envision a space where air conditioners, fans, compressors, and electrical equipment are all managed. The fun part comes next. Each year, the LHC generates around 15 petabytes of data. To work with, a large amount of data is available. Particularly for the Large Hadron Collider, an international partnership has been developed on the computer grid. Great art exists in the mesh itself. The discovery of the Higgs boson, a mystery particle, is the primary goal of the Large Hadron Collider. Scientists never seen these insects, yet they are like ghosts. Its immensity makes it hard to grasp. Producing a lot of Higgs bosons every minute, the Large Hadron Collider is a powerful device. It's similar like putting out a trap for a rare species that has never been discovered despite people believing it exists. There is more to come from the Large Hadron Collider. He is not only looking for the Higgs boson, he is also exploring other uncharted territory in physics, investigates the mysteries of the cosmos, including supersymmetry. A significant setback occurred for the Large Hadron Collider not long after it was launched in 2008. The crash was severely damaged by a magnet failure, which caused testing to be delayed for over a year. However, during its 2009 to 2013 operation, the LHC produced a number of noteworthy findings, such as the identification of the enigmatic Higgs boson. In order to prepare for more fun, the LHC underwent renovations and rebuilds in 2015 following its first successful mission. Its second run lasted from 2015 to 2018, after which it was put on hold until April 2022. Imagine the Earth's magnetic field as a shield that surrounds the planet. This balloon had an unexplained explosion that day. It wasn't a temporary issue either. It was quiet for 14 hours. Envision a stormy night when the window opens unexpectedly, letting in chilly air. Deceased. There was a brilliant aurora in the sky. Fans of Stranger Things will undoubtedly recall the scary antagonist, the Mind Flayer. A few admirers questioned if the Mind Flayer would survive this separation. It's still an intriguing notion, but there's no denying the aurora's entertaining appearance. The co-rotating interaction region, CIR, from the Sun is the cause. Large plasma structures called CIRs are created when varying velocities of solar winds interact. Imagine a rushing waterfall formed by the merging of two rivers, one swift and the other leisurely. The Sun also ejects these CIRs to Earth in conjunction with other phenomena like coronal mass ejections. We witness an aurora, or brilliant light, as they collide. During the early hours of July 7, a CIR collision resulted in a persistent geomagnetic storm. Even the National Oceanic and Atmospheric Administration claims that the storm's coronal onslaught produced a great deal of pressure. The Earth's magnetic field serves as our protection, and interestingly, experts respond, no. Cracks similar to this one frequently occur. These often end soon. Recent experiences, however, have demonstrated that this procedure can take up to an hour. Imagine residing in a home where storms occasionally cause the windows to jam. Even when the storm is mostly stopped, some water could still damage the seat. Similar to how most storms can be blocked by our magnetic shields, some energy still manages to sneak through. Harold Frey likened our magnetic resistance in 2003 to a shoddy structure. Most storms are kept out, but every now and then some energy seeps through. Sometimes it's enough to make us stop using electronics or to provoke contemplation in the outdoors. Thankfully, there was no power or radio disruption. Rather, the fear of the northern lights was the astonishment that this cosmic occurrence brought to the inhabitants of the United States and Canada. Here's a secret revealed by scientists. The Sun is getting stronger. In fact, at this stage of the cycle, they had observed more activity than they had anticipated. For us, what does this mean? Easy. Your odds are better if you want to see aurora. In the next 3 years, there should be more color in the sky. Consider the LHC as a huge telescope that aids in the observation of little things in the cosmos by physicists. It has discovered some amazing things, including the Higgs boson object in July 2017. By the year 2021, 59 new hadrons had been found by the Large Hadron Collider. A new element known as the Pentark was found in July 2022. It is made up of a unique mix of quarks. There will be rivalry for time as well. Their ability to turn a profit has become less effective. However, scientists have a secret weapon. They can adapt. The High Luminosity Large Hadron Collider is the name of the Large Hadron Collider that is now being developed. The initiative, which will be launched in June 2018, will provide the Large Hadron Collider a significant boost that will enable it to identify uncommon cosmic occurrences. What then makes the Large Hadron Collider so well known? On his first visit, he found the Higgs boson. New insights on these items are provided by the Large Hadron Collider's second operation. Scientists at the European Organization for Scientific Research, CERN, want to double the data and double the discoveries now that the third phase is set to conclude in 2025. The Large Hadron Collider at CERN is getting ready for an exciting trip. Imagine this. By 2029, after much preparation, this enormous machine will impact things 10 times more quickly than it did previously. There's more excitement to come. This phase is predicted to continue until 2042, when it will have grown by a factor of 10 compared to the conclusion of the third iteration. Now let's explore the fascinating realm of proton collisions. Protons can be compared to colored gum packets. These bags contain tiny particles known as quarks, which are kept together by smaller particles known as gluons. It resembles the dance of nature's minute features. Picture two jelly bean bags colliding with one another. Jelly beans or grains frequently disintegrate and take the shape of identifiable patterns. However, amazing things do occasionally occur. Head-on collision of two quarks or gluons. All of their energy is compressed by this impact and is then released explosively at an absolutely minuscule place. When doctors experience the light of the depths, it is a rare and intense moment. I was taken aback. To put this into perspective, picture yourself attempting to record a unique moment on a rocket that is continually exploding, where each blast creates an image that is 20 times larger than what your smartphone can record. 1 million terabytes of data will be recorded per second if all of this data is gathered. There is too much information here. In actuality, 40 million activities go place every second. The most of them are routine occurrences. This data body contains a single unique Higgs boson. Here comes Trigger, a sophisticated computer that, like a photographer, only chooses hundreds of the most intriguing encounters each second. Scientists would subsequently swarm to these times in an attempt to solve the secrets of the planet. Envision a massive machine attempting to decipher the mysteries of creation. Currently, his primary objective is to locate tiny items that have never been observed before in order to uncover new global mysteries. Now, there are some confusing aspects to this. Imagine them as the world's heavyweights, concealed behind hordes of microscopic items and exhibiting tremendous strength. The majority of experts, however, think that these giants won't be seen during the third phase of the LHC. We'll receive a perspective or guide that resembles a treasure hunt, but with maps in place of real wealth. These illusions are but precursors of a more substantial revelation to come. Perhaps you are already familiar with this. Even though they are invisible, the enigmatic issues in our world are a part of it. Though they are so subtle that they are rarely observed directly, some novels may represent this dark stuff. It's similar to attempting to ride the wind. Although it's invisible, the impact is visible, like to the sound of leaves rustling. We search for additional items that move strangely at the Large Hadron Collider, suggesting the presence of things that are not visible to the naked eye. The hitch is that these signals are sometimes so weak that our searches fail to see them, like trying to pick up on whispers during a rock event. However, Thanks to several improvements in Run 3, we can now more effectively identify these dubious communications using our ears or detecting tools. A great deal. Plans are in place for the Earth's circular collider, a larger, more audacious device. Consider it the older brother of the Large Hadron Collider. The price of a sizable particle crusher might range from 900 to 21 billion euros. Not everyone, though, concurs with this notion. Some contend that we need to think about different significant research approaches in light of the hefty cost. Consider a major radio station situated on the Moon, for instance, or a gravitational wave detector that finds cosmic rippling throughout space. Sabine Hossenfelder, a renowned physicist, thinks that the puzzles we aspire to solve may not be solved by this powerful supercomputer. It's comparable to purchasing a super camera that is unable to detect our new star. A great deal will occur. The way the clues are disclosed one by one, and the additional explanations that come with each level makes it feel like we're in a cosmic detective thriller. Consider them as if they were intriguing TV shows that we would like to binge watch. A recently discovered aberration in the Earth's magnetic field that lasts longer than anticipated is a startling phenomenon. It's similar like discovering a hidden door you never knew existed in your house. What else may we discover next? But experts like Max Laughlin think we could have a problem. Max Laughlin proposed that the Mandela effect, a phenomena where people are transported to other worlds, was created by research conducted at CERN. Laughlin suggested that collisions of high-energy particles at CERN would disrupt space-time irreversibly, propelling humanity in a slightly different path. The Mandela effect, so named because many individuals recall events or details differently from what actually happened, is the situation where many people mistakenly believe that Nelson Mandela died in jail in the 1980s rather than in 2013. The theory's proponents contend that this false recollection is proof of our shift to a different world rather than only a false memory. Laughlin's idea is intriguing, but many in the scientific world still disagree with it and find it to be dubious, displeased. However, there isn't any conclusive proof that they can persuade us of the same reality. But as these ideas spread, people started to worry for their own safety and lives. Establish stringent protocols in the first place to lower radiation levels. Workers employ dosimeter-equipped accelerators and detectors, and radiation risk regions are tightly regulated. Maintain electrical power by using safe engineering practices and protective materials. Another crucial problem is chemical safety, and there are excellent protocols in place for handling and getting rid of dangerous compounds. In addition to routine inspections and making sure that all electrical systems adhere to international standards, the center focuses on electrical safety and fire prevention. Furthermore, CERN values the security of its workers. Employees are more equipped to handle crises like fires, chemical spills, and power outages thanks to training and safety programs. In addition, on-site medical services are offered to handle any medical emergency. The environment's protection is equally vital. Thanks for watching another episode. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.